Polynomials multiplying binomials and trinomials. And let's start with multiplying binomials. Binomials can be multiplied using algebraic properties. We're using the distributive property, the associative property. And the most common method for multiplying two binomials is called FOIL. And it only works for multiplying two binomials. Do not use it for other things like addition. Once you see FOIL, it's only for multiplying a binomial times a binomial. And let's go through the acronym of FOIL. We have FOIL. The F in FOIL will stand for multiplying the product of the two first terms. The O is for the product of the two outer terms or outside terms. And the I is for the product of the two inner terms or inside terms. And the L in FOIL is the product of the two last terms. So we have first, outer, inner, last, or first, outside, inside, last for FOIL. And a problem would look like this. Remember, we're only using it for multiplying binomials. Say we have x plus 3 times x plus 2. Notice how there's no sign in between the parentheses. That means multiply. There's not an add or subtract there. There could be a dot, but most of the time just two parentheses indicating we're multiplying. And we know it's a binomial because each one has two terms separated by one add or one subtract sign. Two terms separated by one add or one subtract sign. So first times first is going to be the first term is x times x. Then for the outer or the outside terms, we have 2 times x or 2x. Inside, we're going to multiply these two for inside, 3 times x. And for last, we're going to multiply 3 times 2. Then we can do x times x is x squared. 2 times x is 2x. 3 times x is 3x. And 3 times 2 is 6. And quite often when we multiply with FOIL, we end up with some like terms. We don't always, but most of the time we will. So 2x and 3x are like terms. We can add those together and get 5x. So in descending order or standard form, we have x squared plus 5x plus 6. All right, new example. Use FOIL. We find the product of the two binomials. So if we just kind of look at this algebraically, if we looked at like a plus b times a plus b, first times first is going to be multiplying a times a to get a squared. Outside a times b is ab. Inside b times a, or alphabetically, is a times b. And last, b times b is b squared. Then we had these two like terms again in the middle. A positive ab and a positive ab would add up to positive 2ab. All right, you guys pause the video here, multiply this binomial times the binomial using FOIL, come back and check. All right, welcome back. So the numbers we'd multiply, first, outer, inner, last, FOIL, first, outside, inside, last. And 2x times x is going to give us 2x squared. Then for outside, 2x times negative 5 is going to give us negative 10x. And we really don't want double signs. You really don't just want to write minus 10x here, because when you have double signs, you're just going to make things look far more complicated than they actually are. So just write minus 10x. Then 3 times x is positive 3x. And for the last, 3 times negative 5, negative 15. And we have these like terms again in the middle. We have negative 10x and plus 3x combined to be negative 7x. And bring everything else down. And in descending order or standard form, we have 2x squared minus 7x minus 15. All right, what if we have a couple different variables involved? We still have a binomial times a binomial. We just have a and b in this case. So I can multiply. We still do first times first. 4a times a gives us negative 8a, positive 8a squared. Then for outside, 4a times 3b gives us 12ab. Inside, negative b times 2a, negative 2ab. And for last, I have negative b times 3b is negative 3b squared. Look for like terms. We have like terms here in the middle again, plus 2, positive 12ab, and a minus 2ab, combined to be 10ab. So my final answer, 8a squared plus 10ab minus 3b squared. Now, let's move on. Oh, we got one more example. You'll run into this on occasion, and people all try to distribute the 2. And really, the exponent of 2 here is saying how many times do I multiply the base. An exponent of 2 means I'm multiplying this base 2 times. I have x plus 2 times x plus 2, which is where we want to use the FOIL method. We have a binomial times a binomial to multiply this out. So x times x, x squared, outside 2x, inside 2x, and last times last, 2 times 2 is 4. Combine any like terms. So don't let this 2 mess you up. It's just telling you how many times the base is being multiplied. All right, let's move on to trinomial times a binomial. So a trinomial will have 3 terms. It'll have 2 add or subtract signs breaking it up into the 3 terms, the 3 parts. And a binomial, we know, just has 1 add or subtract sign breaking it up into 2 pieces. And this first bullet is super key important. Multiplying a binomial times a trinomial can be done by using the distributive property twice. Just distribute each term in the binomial to each term in the trinomial. So let's look at what does that look like. Let's look at an example. Let's say we have 3t minus 4t squared plus 2t to the third times 2t minus 5. So I have the binomial here on the right side, and I have the trinomial here. So I'm going to take each of these 2 terms in the binomial and distribute them, multiply to each term in the trinomial. So I'm going to start with 2t, and I'm going to multiply it to each term in the trinomial. So 2t times 3t gives me 6t squared. Then I'm going to take the 2t, and I'm going to multiply it to negative 4t squared to get negative 8t cubed. Then I take 2t and multiply it to the last term in the trinomial, multiply it to 2t to the third to get 4t to the fourth. Now I'm ready to move on to the other term in the binomial. I'm ready to move on to this subtract 5, or this negative 5. And I'm going to take that negative 5 and I'm going to multiply it to each term in the trinomial as well. So negative 5 times 3t gives me negative 15t. Then I take the negative 5, multiply it to negative 4t squared, gives me positive 20t squared. And then last I have negative 5 times 2t to the third to get negative 10t to the third. Now I've taken care of all the multiplication. I just want to combine my like terms. And if I start with the highest degree and work my way down, I could put it in standard form as I go. So when I'm looking at the exponents, I'm looking at the degree of each single term. 4t to the fourth looks to be the highest term. So nothing to combine with that one. So I'm going to bring that down into my answer, 4t to the fourth. Then working my way down, I want to look at the terms that have an exponent of 3. I have a negative 3t to a negative 8t to the third and a negative 10t to the third. Combine those, get negative 18t to the third. Then if I look at the terms that have t squared, I have a positive 6t squared and a positive 20t squared. Those combine to be positive 26t squared. Then if I'm looking for terms that just have t, I have a negative 15t. And there's no constants to bring down in this problem. So when you multiply a binomial times the trinomial, just think of it as doing the distributive property twice. Find the binomial, take each of those terms, multiply it to each term in the trinomial, and then combine like terms. And I hope that helps you guys with multiplying polynomials. We got one last one for you guys to try. Try this one, come back, check your work. Pause it here. All right, welcome back. So we're distributing the binomial to each term in the trinomial. I can do 4y times negative 2y is negative 8y squared. 4y times y squared is 4y cubed. 4y times negative 3y to the third is negative 12y to the fourth. And now I'm ready to move on to the other term in the binomial, the negative 5. Multiply this, subtract 5 or negative 5 to negative 2y to get positive 10y. Then negative 5 times 2y to get negative 5y squared. And last, negative 5 times negative 3y to get 15y cubed. Then I look at combining like terms in descending order, starting with my highest degree. I have a negative 12y to the fourth, nothing to combine with that. Y to the third, so there's a positive 4y to the third, a positive 15y to the third will give me positive 19y to the third. Then if I look at y squared terms, negative 8y squared, negative negative 5y squared combined to be negative 13y squared. And last, I have a y term of positive 10y, but no other y terms there. So plus 10y for my final answer. Hope that helps you guys all with polynomials, multiplying binomials and trinomials. OUT spells out.